GCE A-level examination, July 2015. This is a Jaffna zonal paper. Let's start with the first question. Find the values of k for all real values of x. X square plus 2x plus 1 is greater than k times x minus 1. So that is the question. Find the values of k for all real values of x, which means x in this inequality must be real. Let's simplify this. X square plus 2x plus 1 greater than kx minus k. Now send these two terms to left hand side. Minus kx plus k. Excuse me. Yes. Greater than 1. Greater than 0. Nothing in right hand side. Now we can rearrange the terms such that we get a quadratic equation. X square, take x terms out, 2 minus k, constant term is k plus 1. Now this is a quadratic expression in LHS. If x is real, then in quadratic equations, if the roots of a quadratic equation are real, the discriminant of the quadratic equation is greater than or equal 0. Discriminant is greater than or equal 0. If x is real, here too delta of the expression x must be greater than or equal 0. So what is this delta? Delta is b square minus 4ac. So the quadratic equation must be in this form: ax square plus bx plus c equals 0. There must be a x square term, x term and a constant term. So b is the coefficient of x term, a is the coefficient of x square term, c is the constant term. So here coefficient of x square term, which is a, is 1. This is 1. Coefficient of x term is 2 minus k, constant is k plus 1. So delta is 2 minus k is b, square of that, b square, minus 4 into a is 1, into c is k plus 1. That should be greater than or equal 0. Now simplify this. 2 minus k whole thing square gives us 4 minus 4k plus k square. Remove brackets, minus 4k c is 1. Minus 4 into 1, minus 4. So plus 4 minus 4 get cancelled. Now the terms are k square minus 8k greater than or equal 0. Now factorize. Take k out. It is k minus 8. Now when we have an inequality, we have to factorize like this. So k is a factor, k minus 8 is the second factor. Now draw the number line and mark the values of k. K values mark කරන්න ඕන number line එකේ. From this factor, we get k, the value of k as 0. From this factor, we get the value of k as 8. So this is 0. This should be 8. Now you have to consider any value between one of these ranges. Your value can be less than 0, between 0 and 8, and greater than 8. මේ ranges තුනේ කැමති range එකක් select කරගෙන ඒකේ කැමති value එකක් මෙන්න මේ expression එකට inequality එකට substitute කරන්න ඕන. So I'm going to take k equal minus 1 in this range. So when I substitute minus 1 here for k, it is minus, we want the sign, we want only the sign, into substitute minus 1 for k in this bracket, minus 1 minus 8 is minus 9. So it is minus. So what is the final output? What is the final answer? Minus into minus is plus. In an inequality like this, the pattern of the signs that changes alternatively. එක වෙනස් වෙනවා. Plus minus. That changes. So first range is positive, second range negative, once again third range is positive. Okay, done. Now this inequality represent value of this side k. Value of k into k minus h is greater than or equal 0. Greater than 0 is positive. Greater than 0 is positive. So what are the ranges that give us positive? These are those ranges. Positive. So when we have equality, we have to shade these places as well. So we can write the answer. Our k can be less than or equal 0 and k can be greater than or equal 8. This is the answer. Second question, okay. For a comma b, element of real number set. So a and b are real numbers. If modulus a is less than 1 and modulus b less than 1, then show that mod a plus b is less than mod 1 plus ab. Okay, so we have to consider these two datas and prove this inequality. Otherwise, we can consider this as a data and then prove this side. Either method of these two is correct. මේ දෙකෙන් ඕන එකක් කර හැකි. But the easier one is to consider this as the data because that contains a full inequality with lot of terms. It is like solving an inequality starting from LHS. We can start from LHS and prove RHS, or else we can start from RHS and prove LHS. Either side is correct. Normally we select the side with many terms, many expressions. So here I'm going to start with this one. So consider that a plus b mod is less than 1 plus ab mod. So I'm going to square both sides. A plus b square to remove the effect of modulus. That is the reason to square both sides. When we have modulus, we can square. Because for modulus, if I simplify mod a plus b, it is plus or minus a plus b 2. And then we can't work with one sign. We have to consider plus and minus always. To cancel that effect, we can square both sides. Now take RHS term to left hand side. Now you can consider this to start the question. මෙන්න මේ step එකෙන් තමයි අපි පටන් ගන්න. We are starting from that. So I am going to consider a plus b square minus 1 plus ab square. Then square these two expressions. It is a square. Without squaring, I can consider this as difference of two squares. Here a plus b square term, 1 plus ab square. In between we have minus. So this is a square minus b square, difference of two squares. So we can write the factors. A plus b is one factor, 1 plus ab is the other factor. In one bracket we can put minus, in the other bracket between the two terms we can put positive. Now simplify. A plus b minus 1 minus ab, here a plus b plus 1 plus ab. Then we have to factorize this further. Either we have to factorize this, but I think it's better to square both sides, square both terms. We can't factorize that after considering difference of two squares. So I'm going to square both expressions. I'm getting a square plus b square plus 2ab. Minus times square of 1 plus ab is 1 plus a square b square become minus when multiplied by the negative sign in front of the bracket. Middle term is 2ab multiplied by minus. Now I can cancel plus 2ab and minus 2ab. Now these are the terms a square plus b square minus 1 minus a square b square product. Now consider a square minus a square b square separately and minus 1 minus b square separately and factorize. There is a common factor for first two terms, that is a square. So when I take a square out, it is 1 minus b square inside the bracket. This is plus b square. Then when I take minus 1 out from these two, we have 1 minus b square inside the bracket. Now from these two, 1 minus b square is a common factor. Inside brackets we get this. Now as a data, not as a data, yeah, I considered this side, but uh, not the exact modulus expression. I took this one after doing this simplification. මේක පොඩ්ඩක් simplify කරලා mod එක මෙන්න මේ වගේ එකක් අපි හදාගත්තා. ඒකෙන් තමයි අපි question එක start කරේ. Then these two can be considered as datas. ඒ datas දෙක consider කරොත්, see, it is given that mod A is less than 1. Square both sides, then we get a square is less than 1. And the other one is mod B less than 1. Square both sides, b square is less than 1. So if we consider these two things, if a square is less than 1 according to this data, if a square is less than 1, what can you say about this bracket? Final sign of this bracket, it should be negative. It should be negative because we are substituting a negative value for a square. Then that negative value minus 1 become negative. Then b square is negative. B square is also negative. So when we substitute a negative value for b square, 1 minus another minus value, we don't know the value, another minus value, minus into minus will give us plus. So final output is 1 plus value. So 1 plus value is positive. එකට තව positive value එකක් තමයි add වෙන්නේ. ඒකට answer එක positive. Then this product, see the product is negative because one term is positive, the other term is negative. Plus into minus is minus. So this result is less than 0 minus. This product is less than 0 because it is negative. Now I can write a plus b whole thin square minus 1 plus ab whole thin square is negative less than 0. Then send the second term to right hand side. We get this. Now take the square root. Square root. When we take square root, we have to put plus or minus. Take square root in both sides. We have to put plus or minus. So instead of plus or minus, we can put modulus. Plus or minus when what the modulus is. So this is the final answer. We use these as data. Even though I considered this RHS1, the second expression first, to have this kind of a expression. That was the start. ඒකෙන් තමයි අපි start කරේ. But at the middle of the question, these two are considered. So starting from these data, we proved this. Okay, third question. Find the value of limit. Limit problem. Limit of x tends to minus 1 sine. So this is a quadratic expression given as the angle for the sine ratio. X square minus x minus 2. So you know when we have a sine something for limits, this is a theorem. When the angle of the ratio tends to 0, angle, let's say it is x, when x tends to 0, value of sine x divided by x is equivalent to 1. Sine x over x, same angle. If you have the same angle, and also we must have the limit of that particular angle going to 0. Then the answer is 1. Answer is 1. So here factorize x square minus x minus 2 expression. Factorize it. We can directly factorize. To have x square, we must have x and x. Then to have 1, I must have 2 as the constant term. I must write 2 and 1 here. To have minus 1x as the middle term, 2 should be negative, 1 is positive. Then only I can get minus 1x. See, minus 2 into x is minus 2x. X into 1 is plus 1x. Plus 1x minus 2x will give us minus x. So these are the factors: x minus 2, x plus 1. Okay, now the angle of sine expression here is x minus 2 into x plus 1, that product. But I don't have that product in denominator. I have only x plus 1. I have only x plus 1. So I have to introduce x minus 2 for the denominator in order to have the same angle. What is missing? X minus 2 is missing. So I have introduced x minus 2. මං අතින් දාගත්ත x minus 2 එක. To cancel that x minus 2, this term I have to multiply the entire expression by x minus 2. Now this part from the theory, this theory is equivalent to 1. Now substitute minus 1 for this bracket to have the answer for that. What is it? 1 into, substitute minus 1 for x, minus 1 minus 2 is minus 3. Answer is minus 3. Fourth question. Express the following in partial fractions. So we have to separate this given fraction into partial fractions. The only difference from a normal partial fraction is here we have denominators, fractions. X term is a fraction, half into x, constant is minus half. So here we have to simplify this fraction further before separating this into partial fraction. So we have x square, multiply the denominator by 2. Before that, let's write this. Now multiply numerator by 2, denominator by 2. Then we get 2x square divided by 2x square plus x minus 1. The two denominators for x term and constant term get cancelled as we are multiplying that by 2. Now this is the expression. Can we factorize the denominator further? To have 2x square, one factor should be 2x, the other is x. To have 1, both must be 1. Then we must have minus 1 when we multiply these two. So if the multiplication is minus, one term should be minus, the other one should be plus. Middle term is positive. To have that middle term, positive middle term giving us a larger value should be positive. This is giving a small value, then it should be minus. Then only we get minus 1x plus 2x. Answer become plus 1x. So these are the factors. Now I have factorized. Now I can write the partial fractions like this. 2x square divided by 2x minus 1 into x plus 1 can be written as 2x minus 1 is a linear factor. For linear factors, we have constants in the numerator. X plus 1 is also linear. Then we have another constant b. Now multiply this entire equation by this denominator. When I multiply that, we are left with 2x square equal. Then when we multiply these two here in this fraction part, 2x minus 1 get cancelled. Remaining factor is x plus 1. So when we do the same thing for this fraction, x plus 1 get cancelled. 2x minus 1 is remaining. Now compare coefficients. Comparing coefficients, take x square terms. We won't get x square terms in LHS. Oh, I have done a mistake here. First, before factorizing, we have to consider the degrees of numerator and denominator. Here the degree of numerator, that means the term with highest index for x. What is that number? Highest index of x is 2. So degree is 2. Here in the denominator, what is the degree? Term with highest index for x is, that is 2. So both degrees of numerator denominator are same. Then apart from these two usual partial fractions, we have to place a constant. So that constant is k. We have to consider that 2. So k is also multiplied by the two factors 2x minus 1, these two factors, 2x minus 1 and x plus 1. So that is 2x square plus 6 minus 1. So I can write that here k into 2x square plus 6 minus 1. So when we compare x square terms, in right hand side we have k into 2x square giving us 2k as the coefficient. which is equivalent to 2 here in LHS. So K is equivalent to 1. K is 1. Now consider, I am taking this here. Now compare x terms. In RHS we have a into x, a into x, then b into 2x, coefficient is 2b. Here k into x, coefficient is k, is equivalent to no x term in LHS. So no terms, coefficient is 0. We don't know the value of a, we don't know the value of b. K is plus 1, so send plus 1 to the other side, minus 1. This is the first simultaneous equation. Now compare constants. Here we get a into 1, a, then b into minus 1, minus b, k into minus 1, minus k. No terms, no constant terms in LHS. So it is a minus b, send minus k to the other side, plus k, k is 1. This is second simultaneous equation. Simplify 1 and 2. Add, no, subtract 1 and 2. 1 minus 2. A minus a get cancelled. 2b minus minus b. 2b minus minus b give us 3b. Minus 1 is minus 2. Therefore b is minus 2 over 3. From 1 I can write a plus 2b. b is minus 2 over 3 equal to minus 1. Plus into minus minus. This is the fraction. Now send minus 4/3 to the other side. When we simplify, we get the answer of a as 1/3. Now you can use a, b, k to write the partial fractions. A is 1/3 2x minus 1. B is minus 2/3 2 over 3 x plus 1. K is 1. So it is plus 1. This is the answer. Fifth question. The same theory for both sides, LHS and RHS. Sin x plus cos x, a square plus b square, square root term, a square plus b square, square root is root 2. Coefficient of sin x is 1. Coefficient of cos x is 1. So 1 square plus 1 square square root is root 2. So take that out. Root 2 inside brackets we get sin x 1 over root 2 plus cos x 1 over root 2. RHS a square plus b square term is also root 2. එයාගේ coefficient එක තියෙන 1 1 කියලානේ 1 times sin 75 plus 1 times sin 75. Then it is root 2. So we have sin 75 1 over root 2 plus cos 75 into 1 over root 2. Now root 2 get cancelled. Then for 1 over root 2 I can write cos 45 here. That is sin x into cos 45 plus this is cos x. For 1 over root 2 I can write sin 45. Then I have that sin a plus b form. This is sin a cos b plus cos a sin b. A is x, b is 45. Then I can write sin x plus 45 for LHS. Here for RHS also we can do the same thing. Sin 75 sin cos 45, not sin. cos 45 plus cos 75 into, for that 1 over root 2, put sin 45. For LHS, it is x plus 45. For RHS, it is sin 75 plus 45. Okay. This is the theta angle. This is the alpha angle. So in general solutions, we know if sin theta equal sin alpha, theta, according to general solution theory for sine, the formula is n pi plus minus 1 to the power n alpha. So this is the theory. This is how we get that equation. So here we have sin x plus 45. So it is x plus 45 is the angle equal n phi plus minus 1 to the power n alpha. Alpha is 75 plus 45, that is 120. So we want x is n phi plus minus 1 to the power n 120 minus 45. So this is the final answer. N is an integer. We can change the value of n from, we can put any integer for n and obtain solutions for x. So this is the equation that represents the solution set for x.